All right, let's look at some information on phase changes. So phase changes deal with states of matter. And I'm sure you've looked at some of this before in terms of solids and liquids and gases. It's defined as a part of matter that has uniform properties throughout the entire substances. So we have solid, liquids, gases, and plasma. We don't deal with plasma a whole lot in our class. Changes between states are called phase changes. It's caused by a change of heat or pressure, but more often heat is what we think of. Heat and temperature are not the same thing. We use them interchangeably, but that's not always correct. And I hope to take you to the next level and teach you a little bit about that. So temperature is a measure of the average kinetic energy of the particles in a substance. So in physics, you'll learn about kinetic energy, which is the energy of motion. So kinetic energy is directly related to the speed of the molecules. The faster the particles or the molecules are moving, the higher the temperature. So they'll be moving quicker, which results in a higher temperature. Heat, which is going to be our next topic, is a measure of energy in the unit joules. For our class, higher temperature means more heat. So we measure the energy by using temperature. But temperature is a measure of the average kinetic energy. So if we take a look at solids, and here's some examples of solids. Solids have molecules that are tightly packed together. They have high potential energy. They have more bonds holding them together and holding them in place. Molecules greatly affected by intermolecular forces, and those are the forces that are holding those molecules together. The particles vibrate in place, so there is some motion, just not enough for us to be able to notice it. They're very dense, and they're not easily compressed. We can't make compressed solids more than they are. Liquids, the particles are not so tightly packed because liquids flow and they can be poured. And there's some examples for you. They have a medium amount of potential energy. Particles are affected by intermolecular forces, so they have surface tension, which is the ability of a liquid molecules to stick together. That's what allows bugs and other insects to crawl on the top of water. Adhesion is the ability of water to stick to other compounds, and cohesion is water sticking to itself. So this is what allows water and different liquids to sort of stick together and flow like you see in the waterfall or you see in the honey in the spoon. And gases, the particles spread out as the container will allow. So they'll fill that whole container. We have high kinetic energy. The particles are moving very quickly, as fast as 1,000 kilometers per second. They're moving all over the place, and that goes back to that kinetic energy that we were talking about earlier. They have little effect of intermolecular forces. There's not much holding those different molecules together because they're moving around so quickly. They have a low density, and they can be compressed, so we can put gases under pressure. So if we go ahead and we compare these three, and we look at some of these properties, solids are rigid, and liquids and gases are not. Solids have a fixed shape. Liquids and gases take the shape of their container. Solids have a fixed volume. Liquids will have a fixed volume, but gases do not have a fixed volume. We can't really squish or compact solids or liquids any more than they are, but we can with a gas. So phase change is when a substance changes the state of matter. It requires either the input or removal of energy or a change in pressure. So we either have to give heat or remove heat in order for this to happen. During a phase change, the actual change, the temperature does not change, but the amount of energy does. That's a pretty key idea, and I'll show you that in a graph. The energy goes towards breaking up those weak forces between the particles. And when two phases exist at the same time, it's called equilibrium. So absorbing energy is the red line, releasing energy is the blue line, and these are the ones that we're familiar with. So let's start with that solid down in the bottom left. If something is absorbing energy, solid, let's think of ice, it's absorbing energy, it's going to melt and turn into water. If it's releasing energy, if we look the other way around, a liquid, if it's releasing energy, is going to freeze into a solid. When we look at liquids to gases, if we give heat to a liquid, it's going to boil or evaporate into a gas. And if we take a gas and we take that heat away, it's going to condense into a liquid. And let's add this one in. Sometimes solids can go directly to a gas, and we call that sublimation. So sublimation, there's a few compounds that do that. Dry ice is one. So solid carbon dioxide goes directly from a solid to a gas. Iodine also does that. The opposite, which isn't as common from a gas to a solid, is called deposition. Changing states of matter. So if we're looking at things that are melting, it changes from a solid to a liquid. The temperature at which the substance changes from a solid to a liquid is called the melting point. Melting is when matter absorbs thermal energy, so we add heat, and heat energy is added to the particles so they move faster and faster and those bonds break. Freezing is the change from a liquid to a solid. The temperature at which the substance changes from the liquid state to the solid state is called the freezing point. Energy is released during freezing. The attraction between the particles begins to pull the particles closer, and this is how the solid is formed. After all the liquids become a solid, the temperature begins to decrease again. Vaporization is when we make steam. It's a change from a liquid to a gas. The temperature of the substance doesn't change while the vaporization is going on, and I'll show you this again in a graph. The substance absorbs thermal energy, so we speed up the particles throughout the liquid to change it to a gas. And there's two types of vaporization: boiling, matter changing from a liquid to a gas throughout the entire liquid, or evaporation, matter changing from a liquid to a gas on the surface of a liquid. So water will evaporate, but only will evaporate from the surface, whereas boiling takes place throughout the whole amount of liquid. Condensation is the change from a gas to a liquid. As a gas cools down, the particles slow down, and when they slow down enough for their attractions to bring them together, droplets of liquid begin to form. Sublimation, and here's a picture of that dry ice that I referenced earlier. The change from a solid to a gas, it skips that liquid state. The surface particles of the solid gain lots of energy quickly, and they just sort of skip past that liquid stage and go directly into a gas. It's great to use dry ice for shipping very cold things because you don't end up with puddles of water anywhere because it just goes directly into a gas. And there's our example, dry ice. Deposition is the other way, when a gas transforms into a solid without going through a liquid state. Energy is removed very quickly, changing the gas to a solid. So the moisture in the air contacts that cold pane of glass and forms frost. It goes from that moisture in the air to ice on the window. And now let's take a look at this phase change. So if we start with ice down in the bottom left here, we're going to add energy through this whole graph. But if you notice, water has a melting point of 0. And there's a flat line, which is right here, where you can see this flat line here. And what happens is that this temperature will stay at 0 until all of the ice has turned into water. It won't allow the temperature to rise until there's been enough energy to melt all of that ice. Once we get to all water here, now we can increase the temperature. So this is very cold water, and then this is a little bit warmer water, and this is a little bit warmer water until we get to 100 degrees. And again, this temperature will stay at 100 degrees for a long time until all of that water has boiled. And then the temperature of the steam can begin to rise. So during these phase changes, we're continuing to add energy, but we're not allowing it to change in temperature until that state change has undergone. And then taking a look at a cooling curve here. So this is looking at sort of the opposites. So we're starting with a gas on this side, and the temperature up here is high. So we're reading temperature versus time. Temperature up here is high. Here's our gas. As we cool it down, it's going to start to condense. And that temperature will stay constant until all of that gas is turned into a liquid. Once that liquid is there, so this is very warm liquid. This is liquid that's like 99 degrees because we're looking at water. We're going to go down. The water's going to get colder, 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 colder. And if this is water, we're going to 0. And at 0, it will freeze. And then once all of that is frozen, now we can make it colder and colder and colder. Low kinetic energy particles and solids are not moving very much. High kinetic energy particles and gases are moving a lot. So there's a lot of good topics embedded in all of this. If we read it the opposite direction, we go through melting and we go through boiling. And things to know is that any substance, pure substance that you can imagine, whether it be a compound or an element, has a heating curve and a cooling curve that looks exactly like this. The things that change are the temperatures. So ice will freeze at 0, but other substances have different freezing points. And water will boil at 100 degrees Celsius, but other substances will boil at other temperatures. So the shape of this curve will be the same no matter what substance. And that's actually, I think, a pretty neat thing about chemistry.